We're given a piecewise defined function here. So let's examine this function. F of x is 2x squared plus x minus 6 divided by x minus 2. So this piece is true when x is not equal to negative 2. Now, if we look at this piece alone, 2x squared plus x minus 6 divided by x minus or x plus 2. This is a rational function. The only place that or the only point at which this function is undefined is when the denominator is equal to 0. So the denominator is equal to 0. So when we solve this, we get x equals negative 2. So this piece is undefined at x equals negative 2. Other than that one number, negative 2, we plug in any other number, the function is perfectly well defined. So to the left of negative 2, so if we're looking at the number line, let's say negative 2 is here. To the left of negative 2, the function is defined. To the right of negative 2, the function is defined. So it's continuous on the left of negative 2 and to the right of negative 2. Now the only point at which we need to check continuity is at x equals negative 2. So the function is continuous everywhere except we need to still check if it is continuous at negative 2. So we need to find the limit of f of x as x approaches negative 2. So in order to do this, remember that it's a piecewise defined function. So when x is approaching negative 2, that is when x is getting closer and closer to negative 2, either from the left or from the right, it is defined by the piece, let's write that down, 2x squared plus x minus 6 divided by x plus 2. So as x approaches negative 2, either from the left or from the right, the function is defined by this piece. So limit as x approaches negative 2. If we plug in negative 2, we get a 0 over 0. So let's factor 2x squared plus x minus 6. So negative 6 times 2 is equal to negative 12. Plus 4 times minus 3 is equal to negative 12. Also plus 4 minus 3 equals plus 1, which is the coefficient of the middle term. So we can use these factors to complete the factorization. So this would be 2x squared plus 4x minus 3x minus 6, which is equal to 2x times x plus 2. So we factor 2x out of these two, minus 3 times x plus 2. We factor the negative 3 out and get negative 3 times x plus 2. So that is x plus 2 is a common factor in the next step. So that's a common factor. So that's times 2x minus times minus 3. So that's how we factor it. So that's 2x minus 3 times x plus 2, that's factored completely, and we have x plus 2 again in the denominator. So the factor that was causing the 0 in the numerator cancels with the factor that was causing the 0 in the denominator. We're allowed to cancel the 2 because x approaches -2 but is not equal to -2. So now that we have cancelled the factor that's causing the 0 in the numerator and the 0 in the denominator. We're left with this. So finding the limit of this function as x approaches -2, we plug in the -2. So substitution does work. So that's -4 minus 3, which is equal to -7. So as x approaches -2, the value of the limit of the function as x approaches -2 is equal to -7. The value of the function, so if we plugged in -2, by the definition of the function, it is equal to -7. By definition of continuity, the function is continuous at x equals -2 if the limit f of x as x approaches -2 exists, which means it's equal to a number. The function itself exists at -2, and finally both have to be equal. Since this limit as x approaches -2 is equal to the value of the function as x approaches -2, the function is continuous at x equals -2. So therefore, the function is continuous everywhere. We determined earlier that the only place where we had to check for continuity was x equals -1, because -2, because to the left of x equals -2, the function was continuous. To the right of -2, the function was continuous. Now we've checked that the function is continuous at x equals -2. So therefore, the function is continuous at every point on the real number line, that's -∞ to +∞.